So I decided to do the physics test, and I will put the questions at the end of the video, or send them with this video link. And so the questions are the first question is from chapter 1, problem 3. It is about an automobile company displays a die-cast model of its car made from 9.35 kilogram, so mass is 9.35 kg, and they want to know what is the mass of the gold needed to make the new model. So I decided to use the density formula. So density iron equals the mass over the volume. This is the question. This is the formula. We have the mass, and so we only needed the volume, and the volume is 7.86 6 times 10 cubed kilogram per meters cubed. So V is the volume of the iron used in car, and mass is the mass of the iron used in the car. After rearranging the formula, we get that V equals M over D iron. Then we have the V and we have the M, and so we get 9.35 equals divided by 7.86 times 10 cubed, and we get 1.19 times 10 to the negative 3 meters cubed. This is to celebrate the 1.19. This is to celebrate the 100th year worker recast the iron model into solid gold, and the volume will remain the same for constructing a new car. So this is chapter 1, problem 3. Chapter 2, problem. I decided to choose problem 70 for chapter 2. And it says that two objects with initial velocity of 28 meters per second and VF of 16 meters per second with constant acceleration. So this question has two parts. The first part is they want to know the acceleration with displacement 20 meters. We use the formula V initial squared plus V final squared equals 2AD, because we have constant acceleration, so it's obvious. And we get A alone. A equals V initial squared plus V final squared. Minus, because according to the given, V final squared over 2 times the displacement, and we get the 16 squared minus 28 minus 8 squared, because 28, and over 2 times 20, which is 4.8 meters per second squared. Now for B, he wants the second object travels a total distance of 22. Find its acceleration. So it's just 2 meters difference, but it's total distance, not total displacement, so there's a big difference. So the total distance is 22 meters, total distance. And if object 2 goes from negative 8 meters per second to 0 meters per second, then and from 0 meters per second to 16 meters per second, then you'll have to calculate from negative 8 to 0, and then from 0 to 16. So for the first part, 2AD, we're gonna use the same formula, V final squared minus V initial squared. We're gonna get distance 1 equals 16 squared minus A squared over 2A. This is from negative 8 to 0, and So 64 equals 2a from this is distance 1, and distance 2 is 256 over 2a. And so we're, this calculation plus this calculation is gonna give us the total distance. The total distance. So distance 1 plus distance 2 equals 22 meters. So when calculating this and this, we're gonna get the same meters because they're equal. So 2a equals 160 over 11, and which equals to 7.3 meters per second squared. Yeah. And then for the question 3, for question 3, chapter 3, I decided to go with chapter 3, problem 28. So it's a free body diagram, so it's drawn a free body diagram, and I decided to draw it in here. 90-degree angle, 35, and then this is 16, this is 35 degree, and this they're equal, and this is 16 degree. So he wants to find find the components of its maximum displacement for A when it's parallel and for B when it's perpendicular. The angle of the displacement with respect to the slope is theta, which equals theta. We're gonna add all the angles together. 16 plus 35 plus 90 plus 35, which gives us 140. And so if it's parallel, we're gonna see the angle of its sine or cosine. So we're gonna have the d max, because he wants to know the displacement. D max equals d cosine theta, because here we're gonna see where it's adjacent or hypotenuse, and we're gonna get d cosine theta, and which is the maximum displacement of the splash snow parallel to the surface, and theta is the angle of the maximum displacement. So d max equals 1.5 cosine, because the displacement is 1.5 meters. 1.5 cosine 141, which equals 1.17 meters. Negative 1.17 meters towards the top hill, which equals 1.17 meters. So negative 1.7 up, which is 1.7. And for B, the d max equals, because perpendicular, d sine theta, so it's equals 1.5 sine 141, which equals 0.944 meters perpendicular to the surface. Yes, perpendicular. This is for problem 3 and problem 4. So for problem 4, I decided to go with the question 47. So if we assume the motorist travels west 80 kilometers per hour, then we're gonna have to subtract 80 kilometers per hour minus the 95 kilometers per hour. So 80 kilometers per hour minus 95 kilometers per hour equals 15 kilometers per hour, and it's pointing on the east side, because it's saying that if a police car traveling at 95 kilometers per hour chasing a motorist traveling at 80 kilometers per hour, what is the velocity of the motorist? So it's A is the velocity of the motorist, because he went 80 and then he went 90. So so this is relative to the police car. So B, the question is, what is the velocity of the police car relative to the motorist? So it's switching. So the motorist sees the police car taking up more and more of his rear view mirror. So this means that the police car looks at travels west, because so if the police car sees the motorist relative to the of the of, yeah, if the police car sees the motorist traveling east for A, so for B he's gonna see him walking the opposite, so which means that it's 95 kilometers per hour minus 80, which gives us a 15 kilometers per hour. However, it's the opposite side, which is west. And so for C, it says that if they are originally 250 meters apart, what is the time interval will the police car overtake the motorist? It's 250 meters, so 250 meters divided by 1000, it's 1/4 kilometers. So just making all of these units equal. And so it's D equals V over T, because he wants the time, and we're gonna have that 1/4 kilometers times 15 kilometers per hour, which gives us 1/60 60 hour times kilometers over kilometers, which equals to like 1/60 hour equals 1 minute. So it's gonna take him 1 minute to, if they are 250 meters apart. And as for relative acceleration is 0, because there's no acceleration. No acceleration. So it's no acceleration. No acceleration. So question 5. For question 5, I decided to go with the force exerted by the wind on the sails of a boat as 390 north. So force 1 is equal to 390 north. Force 2 is equals to 180 north. And so I decided to draw a free body diagram. And I decided to go with force of. So force 1, I decided to call force 1 is force of the wind, because it says here that the wind is 390 north. Force 2 is force of the water, which is 180. And we have the mass. The mass of the boat itself is 270 kilogram. And he wants to know the magnitude and direction of its acceleration. So it's pretty easy. We're gonna have to calculate the net force. So let's just call it FR, or it doesn't matter, it's really FR. FR equals the F squared net plus F squared water. We're gonna have to square them all. F squared wind. So we're gonna have to move this F squared net here, equals the F squared water plus F squared wind. So it's at the end we're gonna have square root, and then we're gonna have two values. 180 squared plus 390 squared, and then it's gonna give us plus minus 430 newtons. But we're gonna only use the plus because we're not gonna have a negative. How are we gonna have a negative? Anyways, and then we're gonna have to calculate the F net. So F net equals MA. F equals MA. MA is the solution for everything. It's like the Joker. So F net equals M over M equals A. So A equals 430 over 270, and you're gonna get 1.16 meters per second squared. 430. Make sure. Yes. So 1.16. So to find the direction, you're gonna have to use the tangent. Tangent north and east. F north, so which is the F wind. Wind is going north, water is going east. So tangent inverse 390 over 180 equals 65.2 degrees north of east. 65.2 degrees north of east. Question 6. For question 6, I decided to go with problem 22. Problem 22. We're gonna use the acceleration, which is v squared over r. V is the terminal speed of the child in horizontal direction, and r is the radius of the curve. So ay equals g, gravity for the centripetal acceleration in vertical direction. And so to calculate the net centripetal acceleration is a equals, so ax squared plus ay squared. And we're gonna have a equals, so ax is v squared over r squared and g squared. So we're gonna plug, and we're gonna get 16.7 meters per second squared. So 5.7 over 2.4 plus 9.8 gravity squared, and then 16.7. So then we calculate the force. Force equals a over g, which is 16.7 over 9.8, which is 1.17 newtons. And then the tension in the muscle on both sides of her neck is 55 newtons, is given. And the tension of the muscle on both sides of her neck while she is sliding changes because she's sliding, so she's gonna increase. And then F equals 55 times 1.7, which equals to 93.8 newtons. Yeah. So this is for question 6. And we're gonna have last question, which is question number 7. Problem 7. Problem 7 is, I chose 42. I chose this because I found it like it's more fun. Problem 42 is one of the fun problems, and it's pretty challenging. So he says that the child has 400 newtons, force equals 400 newtons, and is attached to a pair of rope which is 2 meters long. Find the gravitational potential energy. So potential energy, and while she's at the lowest point, and when the ropes are horizontal, and when the ropes are at an angle of 30.08, and C when the child is at the bottom of the circular arc. So for A, we're gonna calculate F equals mg. Mass is 400 newtons. Mass times gravity gives us 400 newtons, and the height is 2 when ropes are horizontal. And so potential energy equals V equals mgh, which equals 400 times 2 times 9.8. This gives us 800 joules. 800 joules. And then we're gonna draw a triangle for the arc, and this is 60, this is 2, let's call this D, let's call this B, let's call this A, and this is theta. So when the rope is at 30-degree angle, let's calculate from B to D. So BD equals like the 2 meters times cosine 1 minus cosine 30, and then you'll get the potential energy relative to B, which is like the volume, the velocity equals 400. So you'll get BD equals 2 meters times 1 minus cosine 30, and then you will get U equals 400 times 2 times, because 2 times 200, okay, 400 times 2, 1 minus cosine 30, 1 minus cosine 30, which gives us 107 joules. 107 joules. Potential energy at the lowest point would be 0 because you're at the ground, so you'll not have potential energy. You'll not have gravity. Gravity is 0, so mgh cancels out. And that's all. Here are the rest of the questions. and I'm gonna put the questions alongside with the video.